Chapter 6, Goal 5. Apply properties of a parallelogram. Last section we talked a lot about different polygons. Now we're going to really focus on quadrilaterals. If you recall, a quadrilateral is a polygon with 4 sides. However, there are special types of quadrilaterals, different properties that apply to very specific quadrilaterals. The first one we're going to look at today is called a parallelogram. Parallelogram has properties based on its sides, it has properties based on its angles, and it has properties based on its diagonals. We're going to focus right now on the properties based on the sides. A parallelogram, as the name might suggest, the opposite sides are both parallel. Make sure we spell it right. So in my diagram, I could mark that by saying segment WT is parallel to segment HS, and segment WH, I'll use 2 arrows to represent a different set of parallel lines, is parallel to segment TS. In addition to them being parallel, a property of the sides of a quadrilateral is that opposite sides are also congruent. So using a different color, I can show that segment WH, using a circle, is congruent to segment TS, which means I can set their lengths equal to each other. And segment WT is congruent to segment HS. Those are the properties based specifically on the sides. Here's how we would apply those. In number 1, it says that we have a parallelogram ABCD. This symbol here means parallelogram. When we're naming this parallelogram, the order that we name it matters as well. If we start at A, then we have to go to the right to B, down to C, to the left to D. We can't mix those up. They tell us that segment AB is 52. Segment BC is 41. Segment CD is 3x minus 2. And segment DA is 9 minus 2y. Because the properties state that opposite sides are congruent, I know that segment AB is congruent to segment DC. I can find x, because they're congruent, by setting those two equal to each other. And 3x minus 2 equals 52. Similarly, segment AD is going to be congruent to segment BC. Because they're congruent, their lengths are equal, so I can find y by saying that 9 minus 2y equals 41. Go ahead, press pause, and solve those. Check your answers at the end. Hopefully you found that x equals 18 and y equals negative 16. Yes, it's okay for the variable to be negative so long as it does not make your segment negative. If I substitute negative 16 back in for y, that would give me a positive 41 as my segment length. So that one is okay. Next, we'll talk about a parallelogram and angles. If a quadrilateral is a parallelogram, opposite angles are congruent. We know that because opposite sides are parallel. Because these are parallel segments, I can state that opposite sides are congruent. There's a long proof that we would have to go through. It's not as obvious as you might think. But in this case, angle H is congruent to angle T, and angle W is congruent to angle S. I know back in chapter 3, we talked about how if we had these two intersections, you can't compare on a diagonal. And that's true. The only reason this still works is because of the second bullet point here. Consecutive angles are supplementary. if WT is parallel to HS, these are considered same side interior angles, so they are supplementary. Because WH is parallel to TS, H and S are same side interior angles, so they are supplementary. Since W and S are both supplementary to H, that's how we can conclude that W is congruent to S. That's all fine and good, but the biggest part of this chapter is that we need to apply those concepts. So when we're given a parallelogram, there's 4 things we can now conclude. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. And consecutive angles are supplementary. I need both in this case. I need to know that opposite sides are congruent because they want me to find the length of segment YZ. Segment YZ is 8a minus 4, but it's congruent to segment WX. So I would start by setting 6a plus 10 equal to 8a minus 4. I'd use algebra to solve for a, and voila, the algebra magic gave me a equal to 7. I have to substitute back in to 8a minus 4 to find the length of YZ. In this case, 8 times 7 is 56, take away 4, YZ is 52. Here they want me to find the measure of angle X. I don't know anything about angle X except that it's congruent to angle Z. Because it's congruent to angle Z, then the measure of angle X is also going to be 9b plus 2. That's only helpful if I know B. To find B, I use the theorem that these consecutive angles are supplementary. Supplementary means they add to 180. So I have to take 18b minus 11 plus 9b plus 2 equals 180. The algebra magician comes again, and b equals 7. To find the measure of angle X, then, I substitute 7 in for b. 9 times 7 is 63, plus 2 is 65. So the measure of angle X is 65 degrees. The last thing we need to talk about with parallelograms today is its diagonals. What's true about the diagonals of a parallelogram is that they bisect each other. Because it's a quadrilateral, there are only 2 diagonals. Segment HT in this case, and segment WS. All I know about them is that they intersect each other at their midpoints. So segment W, and if I called this intersection point M, WM is congruent to segment MS, and HM is congruent to segment MT. Here's how we would apply this new property. They tell me that it's a parallelogram, and they give me Fj is equal to 4z minus 9. Go ahead and label everything that they told you. Because it's a parallelogram, I know these segments are congruent, and I know these segments are congruent. So when they ask me to find JG, I can set these segments equal to each other. 3W equal to W plus 8. So 2W equals 8 and W equals 4. Use substitution to find that JG equals 12. They want me to find FH. I have to start by setting these segments equal. 4Z minus 9 equals 2Z. So 2Z equals 9 and Z equals 4.5. To find FH, I'd substitute in for one of these. Find JH maybe. 4.5 times 2 is 9. FH is both of these. Since they're the same, I can multiply the 9 by 2. And FH is 18. The last thing for today is I want you guys to try to put all of these pieces together and try this last problem. When you come to class tomorrow, you'll get the answer to this last problem. Try it, show up at class with your answer. Find all the variables. Find X, find Y, and find Z. Actually, here, I'll give you guys your answers. I want you guys to figure out how we can get those as our answers. Those are your correct answers. Tomorrow in class, you'll figure out how, if you haven't done it this evening. The last thing on your notes is this flow chart. These are all the different types of quadrilaterals we are going to look at in this chapter. Today, we've taken quadrilaterals and broke it down into parallelograms. That's the first type of special quadrilateral that we've looked at. We will also break parallelograms down into two different types of parallelograms, and even a third that meets both of these criteria. We will talk briefly about two other types of quadrilaterals then.